All right, awesome. Good morning. Good morning. We are continuing in Chapter 6. I do have a kind of a silly poll up on your favorite color. Very encouraged to see that no one has foolishly answered cyan. So I do have hope for you guys. Let me end the poll and show you the results. That there is a clear winner. So blue kind of dominates favorite colors, and then green. So not as much Baylor Spirit as you might have hoped for, but it is what it is. We are continuing with Chapter 6, Variables and Calculations. You should see the slide, Chapter 6, Variables and Calculations, I hope. If not, as a brief recap, we talked a lot about basic math and data types. The data type that you're working with is going to drive how Java does the math and the kind of numbers you'll get as a result of the calculations. Java is what's called a strictly data typed language, which means every number has a data type. Even if you just type in a number like 2, it has a data type. It would be an integer data type by default. And if you just type in a decimal number like 3.14, it will have a default data type, which is a double or double precision floating point number. And floating point numbers and whole integer numbers are different. They're treated differently because microprocessors are designed to handle those types of numbers differently. There are entire pipelines to handle integers versus separate pipelines to handle real or floating point numbers. So languages that can make that distinction, like Java and C++, can take advantage of the design of the microprocessor, at least theoretically, more efficiently than non-strictly typed languages. The downside is, well, we've just started to get to the downsides. This is kind of the chapter where we look at the downsides. We did note last time that adding 0.1 together 10 times to get 1, and we talked about multiplying 10 times 0.1 to get 1, and we did that math and noted that we got two different results. They were really close results. They were virtually 1, but one of them was 0.999 and 16 nines, which again is super close to correct, but I guess the point is it's not actually correct. And one of the results would be if you're writing code that is waiting for a variable to hit 1, and it should hit 1, but it doesn't, it hits 0.9 and 16 nines, then the code you write waiting on that will not run. The if statement won't ever hit true, or the loop won't ever hit false to kick you out of the loop, or whatever the case may be. You have to be really careful about writing these types of statements. And if you have decimal numbers and you're driving, for instance, an if statement based on a decimal result, you want to be really careful that code it in such a way that if it's close enough to one that you need to quit, that's how you write it, rather than writing it so that it has to hit exactly 1 for something to happen. Second big topic we talked about was variable scope. And just as a very quick recap, the location in your code that you declare a variable determines where in your code you can use that variable. The widest scope is the instance variable, which is declared outside of the body of any method, but inside of the class. We typically put those up at the top of our code, right after the class declaration, but that's not a requirement. The requirement is simply that instance variables are not declared inside of a method, but are declared inside of a class. And you can see those throughout the class. The more narrow scope is if you declare a variable inside of the body of a method, then it's scope restricted to that method after its declaration in that method. And then similar in scope is the method parameter. A variable declared as a method parameter is only visible inside of the body of that method. And then the narrowest scope is declaring a variable or object inside of curly braces inside of a method. So inside of an if statement or inside of a loop that variable is then scope restricted to that inner set of curly braces. And we did a quick activity, scope demo activity. We typed in 3 variables, x, y, and z, and then we looked at where you could use them and where you couldn't. And that's where we stopped here with a slide that said we will move on to this next time. So that's where we're at. Let's keep going. So in general, I think you would agree that doing math in Java is very similar to doing math in other languages, at least in terms of the operators and the manner in which you type calculations. In general, you use the same symbols you would use in other languages or even in a spreadsheet. If you haven't done math, in other languages, then it's the same multiplication, division, addition, subtraction operators that you would use virtually anywhere else. There are then some oddities that start with exponentiations. You'll notice in the table maybe, this is pulled just straight out of the book, but that exponentiation is listed there, but it's all in red, and then in bold it says, this does not work. So you might wonder why I put it in the table at all, and it's simply because everybody expects it to work. There is a way to do exponentiation. Obviously, there would have to be. And for whatever reason, Sun put it inside of the math library as a function or a method called pow. So you use math.pow to do exponentiation, or obviously if you're just squaring something, you can multiply it by itself. The single equal sign is assignment. Incrementing and decrementing are double plus and double minus, so that'll be a new thing maybe to some of you who took the mobile class where Lua does not support the increment and decrement operators, so you have to type it all out as, for instance, x equals x plus 1 or y equals y minus 1 or whatever you want to do. So the shortcut syntax to do that is just, for instance, x plus plus or y minus minus. Once you start using that, it certainly becomes a handy way of typing less, although certainly not. It's not required that you do it that way. You can still type x equals x plus 1, for example. And then there are a variety of slightly more esoteric shortcut operators, increment by, decrement by, multiply by, and divide by. Also, if you're coming from other languages that don't have those are handy in some types of programming where you just do a lot of that sort of work. All right, precedence. So obviously Java follows mathematic precedence just like any other programming language or spreadsheet or even probably your calculator. So increment and decrement operations are done first, followed by multiplication, modulus, and division, followed by addition and subtraction, and then at the last, assignment. So if you write a math statement using operators like this, Java will look at it and will look at the right-hand side of the equation, that is to the right of the equal sign, and it will start processing it following mathematic precedence. And in cases of equal precedence, it will process the expression from left to right. If there's any confusion at all, you can always use parentheses to control the order of operation to get the result that you want. Mixing data types, this is, I don't know, for whatever reason, this if these were bulleted, it would be the fourth bullet, which is mixing data types in an expression should be done cautiously or not at all. That's one of these things that's a little bit of a preview of some of the difficulty that's yet to come in this chapter. You do absolutely want to be cautious about writing expressions that have more than one data type in them, or, I mean, just to be really specific, you want to be cautious mixing, say, decimal numbers and integer numbers in math that you're writing, because you end up with a situation where Java has to make assumptions about what the data type of the result is going to be, and you have to understand how it makes those decisions to write the expression to work properly. But again, that's a little bit of a preview of what is to come. We're not there yet, but just keep that in the back of your head that this is going to be potentially a problem. All right, literal data types. So again, there's no such thing as untyped data. If you don't explicitly type a number that you're using, Java will assign a data type. Again, for integer numbers, it will be an int integer or a 32-bit integer. For decimal numbers, it will be a double precision floating point number. And for a lot of what we do, these are perfectly fine defaults, which is maybe why they were chosen, as the defaults. But occasionally that's not what we want. We want to, for instance, I mean, a really easy example is if you wanted to type in a 16-digit credit card number. That's an integer number. Obviously, there's no decimal places. The problem is those 16-digit numbers exceed 2 billion, which is the range for the integer data type, plus or minus 2 billion. So if you try to type it in and assign that to a long variable, you'll get an error that essentially that your number does not fit. So the way you enter it is you have to type the literal value, and we type literal values by using a letter that corresponds to the data type it has or should have after the number. So for instance, to type the number 2 as a long, you would enter it as 2L. If you just enter it as 2, it's an int integer. If you want it to be a long instead, you type 2L. And this is where I've got, in this slide, I show it as 2L 2 times. And I do that on purpose because that first one I used a lowercase l, and you can see that it looks like 21. And certainly if you're reading over somebody's code or even your own code that you had written some time ago, you might look at that and certainly at least pause and think, wait a minute, did I type 21 or did I type 2L? This is an interesting place where in virtually every case, Java is case sensitive. I had a lot of case in that sentence, but Java frequently cares about the case, whether it's capitalized or not, and it makes a difference, except here. You can type a lowercase l or an uppercase L or any of the other letters, and Java will treat those as the same thing. And in lots of cases, for instance, to do the same thing with floating point numbers, if you wanted to create 2 that was a float, you put an F after it. I do recommend, as you're doing this, you always use the uppercase L, just as a style, maybe as a style guide, because it makes it easier for everybody to read. Okay, this is the slide that can sometimes throw people. So there's a rule up at the top in gold and italicized, and it just says, in expressions involving a single data type, that data type will be used to evaluate the expression. So in other words, Java, which is a strictly data type language, pays attention to the data type, and if you use numbers of a given data type and multiply them, say, it will find the result in the same data type. So as an example, just as a first example, an expression involving integers, every part of the expression will be conducted using integer math. So that's good in some ways. You might recall last time I mentioned that there are certain types of integer-only calculations that microprocessors can handle without any error. So, adding 2 and 2 together as an example, Java can do that correctly. It will select the right registers on the microprocessor. Those numbers will be represented perfectly. The result will be perfect. That's a good thing. But let's try a slightly different example. And if you have a calculator with you, or you can open up the calculator app on your computer, you might want to follow along with that, but it actually doesn't require that. So the math I want you to do, either on a calculator or in your head, is just what is 1 divided by 2? You might have been expecting something more complex. I don't know. And I do want to wait so that if you're unsure about the result, you get a chance to think about it. Or if you were sure about the result, I'm hoping if I pause long enough, you'll become uncertain. Like there must be something more. All right, so hopefully you guys have a number in your head that you've committed to as the result. Maybe go so far as just to speak it out loud, just so that you're fully committed to it. And then I'm going to move to the next slide. All right, so many of you would have gotten 0.5, and you probably did that without a calculator. I don't know how many of you grabbed a calculator and double checked. Unfortunately, 0.5 would be wrong. Wrong as in that's not the correct answer. So that's sometimes where people do a double take, look up from the paper that they're reading, and think, wait a minute, he asked me to divide 1 by 2. The answer is 0.5. I know it's 0.5. I can do that in my head, and yet he's saying that's not correct, so what is going on? I've got a screenshot there just to prove it to you. If you're one of the people who are skeptical, I've done math a little bit of math in that screenshot. It just says system.println 1 divided by 2 double equals 0. All that does is test. Double equals is the Boolean test for equality. So it says, is 1 divided by 2 equal to 0? And you can see in the result section, it says true. 1 divided by 2 is 0. Okay, so how on earth could that be the case? Well, first off, they're both integers. One's an integer, two's an integer. We didn't specify that they were longs, so they get the default integer data type. So it's integer 1 and integer 2. That means there's no combination of data types. There's no mixed data types. It's all integer data types. That means Java will proceed using integer math. Integers don't have decimal values. That's the thing. So when you divide 1 by 2, where you might think you would get a half or 0.5, you don't in integer math because there's no such thing as a half or 0.5. You just get 0. You can think of it like it truncated the 0.5, but in fact, that's not really true. There never was a 0.5, so there was nothing to truncate. But I don't think there's any harm in remembering it as, okay, integer math will truncate. Just as long as you know it didn't actually truncate because there never was a decimal part to truncate. All right. So when we do integer-only math, we're going to need to be cautious. There are several things that I'm going to say when doing math that maybe you should kind of throw up a red flag for yourself as you're writing it. And one of them will be, am I writing an expression involving all integers, and am I doing any division? Because if I am, that should throw up this red flag that, wait a minute, any decimal results won't exist. And do I need those decimal results, or is it okay not to have the decimal results? All right, what about mixing integer and decimal math? So this is where it gets a little trickier because there's a mixture of data types and Java's then stuck trying to figure out, okay, but where do I do the math on the microprocessor? Which of the registers do I use? Do I use the integer ones or do I use the floating point ones? Because if I use the floating point ones, then we've got the inaccuracy issue of representing certain non-terminating binary numbers. And in fact, Java will have to make a call about data types as it's evaluating the expression. It has to do the math using a single data type. So what it will try to do is convert everything to the same data type, except it will only do this in very specific cases. This process of conversion isn't called conversion, it's called promotion. And when it occurs automatically, it's called automatic promotion. So when Java does it, it's called automatic promotion. It almost sounds like magic. I've just laid out all these issues with doing math in a strictly typed language. And then I've said, but hey, there's this automatic feature that makes it all work. That it does sound good. I agree. There are, however, limits to what automatic promotion will do for you. Okay, so let me explain automatic promotion and then see if you have any questions about it. The key to understanding mixing data types is simply that Java views the data types as existing on this continuum of which you might call information value. The lowest information value data type is the byte, the 8-bit integer. And then if you can read that, it just moves up the continuum to short, int, long, float, and double. So the highest information value data type is the double precision floating point number. It's an easy concept, and once you get the hang of it, it makes sense. In the meantime, you might find yourself referring back to this continuum a lot. But again, lots of those data types are ones that we never use, or we certainly won't be using in this class. So we predominantly will use double and int, and the occasional long to handle integers that don't fit as int integers, and the occasional float if we're working with colors or other a handful of other Java methods that require floats. Otherwise, we'll be using doubles and ints. But you notice in the continuum that int is below double. So double is the higher value data type in that continuum. And so what is automatic promotion? Here's the rule. When performing a mathematical operation involving values of different primitive data types, those on the continuum there, the lower data type is automatically promoted to the higher type to complete the operation. Got a couple of parenthetical comments in the rule, just as you read it maybe a second time, you can add those in. So I'm going to read it a second time and add them again. When performing a mathematical operation involving values, those could be literals or variables, of different primitive data types, those are those types in the information value hierarchy right above, the lower value data type is automatically promoted, that's also called widened or widening, to the higher value data type to complete the operation. So if you're doing something, say, with an integer and a double, the int can be automatically promoted to a double for Java to do the math. And it will do this without warning or without any sort of report that it has done it. So there are a few notes, which is the next slide titled Notes. Number one is what I just said. Promotion is carried on without notification. Doesn't warn you ahead of time. There's no exception or warning at the console. It just does it and keeps going. That's number one. That's not necessarily a bad thing. These notes aren't meant to be issues or criticisms. It is what it is. Number two, there's no such thing as automatic demotion or narrowing. Java will never automatically change the data type downward on the information hierarchy on the prior slide to make the math work. If you want to narrow something or demote something, you have to do it manually using a syntax that's called recasting, which we'll discuss next. Number three, automatic promotion will only ever occur on the right-hand side of the equation, RHS here meaning right-hand side. No data type changes are possible on the left-hand side, LHS. Promotion and recasting can only be done to the right of the equal sign. Number four, and this is a bit of an oddball one to put here because it's not the topic really of the chapter, but it's a common assumption that people make, and I think it actually makes sense to make, and yet it doesn't work, which is why I put it here as a note. So this, of these three, number four is the only one maybe you could consider a disadvantage. So when thinking about text, there is no automatic promotion from char to string. So what is char? Char or character is a single alphabetic digit or symbol. And strings are essentially arrays or sets of characters. So people think when they're writing expressions involving characters and strings that Java will just deal with it by promoting the character to a single character string and then doing whatever you're asking it to do. If you're passing a string to a method which wants a string, it kind of makes sense to think, well, I could just pass it a character and it'll handle that because strings are made out of characters, so it should just be able to deal with that, but it doesn't. And Chapter 7 goes into much more detail about when that's a pain. Okay, before we get to the examples, we need to know how to recast. And the term is kind of weird, but it's analogous to the situation in a TV show or a movie where an actor is recast. I'm sure you've got shows that you watch in which that has happened. In Bewitched, Darren was recast, famously. In Harry Potter, obviously Dumbledore was recast. So the recasting normally occurs because something bad has happened to the actor, or the actor does something bad. In either case, it's a fairly common thing to do. So in programming is essentially the same thing. You're saying, hey, I know that you're an integer, but I really want a double here. So I'm going to recast you as a double so that you'll act like a double in this expression. Conceptually, that's what recasting is it's saying you act like this other data type for the purpose of this multiplication, this operation. After that, you go back. Interestingly, recasting is not permanent. It's a one-time, for the purpose of this operation, act like this other data type to make it work. The syntax is easy, but I remember thinking it looked odd the first time I saw it, so it certainly may look odd. The syntax is to specify the recasted data type in parentheses before the variable. As an example, here's our first example of the day. if we had an integer a and set it equal to 2, and a double d and set it equal to 3.5, so I have two variables, a is an int, d is a double. If I wanted to take the d for whatever reason, and I needed it to act like an integer for the purpose of a calculation, an operation, in this case the assignment operation, what I would do is precede the d with the data type int in parentheses. So you might first off think, all right, but why? I mean, not necessarily why would I want to put a decimal result into an integer variable. That could happen in math. Certainly we might end up with a result that was, had decimal values, but we didn't need the decimal values maybe, and we just want to get rid of them. The bigger question might be, well, but why do I need to do this? Why doesn't Java just, when it does the assignment, if I said int I equals d without the recasting, why wouldn't Java just truncate the decimal values, in this case the 0.5, to make the assignment work? We just got through talking about how Java will do some of this stuff automatically. Why wouldn't it just do that automatically? Okay, but so here's the reason. To make d fit into the integer a automatically, it would have to move down the information hierarchy. Double is higher in the hierarchy than int, so to make the assignment work, to put d into the integer I, Java would have to automatically demote the d to an integer, and it will not do that. That goes back to one of those notes on the slide of notes, which is, let me just flip back to it here just to highlight it. Number 2, there is no such thing as automatic demotion. Java will not move down the information value hierarchy. So the d is a double in that statement, and int is an int integer, which is lower on the hierarchy. Java will not do that. It's going to make you do it, and the way you do it is via recasting. So essentially, you're telling Java, yeah, I know I have a double, but I want it to be an integer for the purpose of this assignment, so I do that by forcing it, by saying, okay, D, act like a double. Your recast is a double for this assignment. Same thing in the other direction. If I said double B equals A, I could recast A as a double by preceding it with the data type double in parentheses. So, but interestingly, that second example there, double B equals double A, you don't need to recast A because A would be promoted. A as an integer is lower on the continuum than the double B. So Java would make that third line of code there in the example, it would make it run without issue using automatic promotion. But of course, you'd have to, well, to some extent, you'd have to realize that Java was going to do that, in the circumstances in which it'll do it, to be confident that you could avoid recasting it. And the other point to make would be that you can recast when you don't need to. It's not an error. So putting the recast as a double here on that third line, double B equals double in parentheses A, putting that recast there is not an error. It will not produce an error. You're just doing something that Java would have otherwise done on its own. So I know if you haven't learned a strictly data type language before, this is a lot of new stuff. The next bit is just thinking through some examples and then talking through them with me. So I'm going to give you some examples, and then I'm going to pause long enough. I hope that either if you're following along live, you have enough time, or if you're watching it, after the fact, I'll leave enough time in there that you could hit the pause button and think through these before we explain the results. Let's say we've got these same variables, A and D. A is the integer, D is the double, and we need to do some math with those variables. So first thing to keep in mind is that although we recast both A and D, those recasts were only for the purpose of that one operation. We didn't change their data types. A is still an integer, D is still a double. Okay, so some examples here. First example is D equals 3.14 times A. So the way you think through something like this is first you ask yourself, is there any mixing of data types? And so looking at it, 3.14, what's that data type? It's not specified, it's decimal. So the default for unspecified decimal literals is double. So 3.14 will be seen by Java as a double precision floating point number. We are multiplying by A, A is an integer. So we do have two different data types. We have a double multiplied by an integer. That's the other big situation where a red flag should go off. When you realize you've got an expression that involves mixed data types, that's going to require a little more thinking with respect to what's Java going to do, and will Java do it, or do I need to step in, and fix it using recasting? But that's the next examples. Here we're just looking for the number, the result. Well, so you have to go back and look at what the value of A was. It's not really super important, but A is 2 on the previous slide. But we have a mixed data type, so what's Java going to do? D's a double, so the result will be assigned into a double precision floating point number. 3.14 is a double, but A is an int. So Java will promote A. Automatic promotion here will kick in because Java can promote the integer value stored in A to a double precision number without, in its view, losing information value. So it will do it. Automatic promotion will kick in. That first statement will work fine, and the result will be twice 3.14, so 6.28. All right, I'm going to keep going slowly. Certainly, again, feel free to pause if you're watching this recorded. D equals A. So again, the first thing you ask is there a mixed data type issue? Yes, there is. D is a double, A is an integer. So we're trying to fit an integer, a number stored as an integer, into a variable that's defined to hold double precision numbers. That is a mixed data type issue. But automatic promotion will still kick in. So A will be automatically promoted to a double to make the assignment work. So D will end up holding the number 2, but as a double, and in Java, it will, if we spit it out to the console, it will be spit out as 2.0. Just to confirm, or if you added it to a text field, displayed it in a text field, it would show up as 2.0. So Java does this just to let you know that, hey, this is not an integer, because here's a decimal point, to prove it to you. So one point of confusion people have at this point is they say, well, wait a minute, A was just recast. That first example, D equals 3.14 times A, you just said you recast A as a double. So in that next line of code, A is already a double, isn't it? So no, recasting only works for one operation. So in the first example, D equals 3.14 times A, yes, A is automatically promoted to carry out the multiplication. Java pulls the value stored in A out, makes it a double precision value, does the math. It does not change A, or it doesn't change what's stored in the variable identified by A. So it's a one-time make this operation work conversion. So when we get to the second line there, D equals A is still an integer. That said, we don't need to do anything to get the second line to work because the same rule applies. A can be promoted to the double for the assignment to be carried out. So no issue with that. Third example, D equals A plus B. Okay, so we might need to look back at the previous slide to see what B was. So B is a double, and it stores the value in A recast has a double, so it stores 2.0. All right, so A plus B, A is 2, but B is 2.0. So we have, again, on the right-hand side of the equation, we have a mixed data type situation, and we may or may not have a mixed data type situation for the assignment to be carried out. You have to evaluate the right-hand side first, find a result, and know what data type it's in to know whether the assignment is going to be affected as well by a mixed data type issue. So we're just looking at A plus B first, right-hand side. We do have a mixed data type issue. A is an integer, B is a double. Same automatic promotion rule applies. A can be promoted, once again, to a double so that it can be added to B using the same data type. The result is 4.0. That's a double. And so when we get to the assignment, to assign the right-hand side into the variable identified on the left-hand side, there's no data type mismatch. So the one recast of A, the automatic promotion of A, the the one automatic promotion of A is enough to get that line of code to evaluate successfully. All right, the last one, C equals D. Let's jump backwards again just to double check. What is C? C is an integer. Treating C as an integer, trying to carry out the line C equals D. The first question then is there a data type mismatch issue? And yeah, there is. Again, the data type on the right-hand side does not match the data type on the left-hand side. D is a double, C is an integer. So to get this assignment to work, automatically Java would have to automatically narrow or automatically demote D to be an integer. It would have to move it down the information continuum. Java will not do that. So this fourth line of code will not run. That will be a compiler error. And you might think, well, wait a minute, you said Java could make changes on the right-hand side. You said it can change data type. But again, the limit is Java will only move stuff up the information continuum, not down. To get this fourth line of code to work, Java would have to move D down the information value continuum. You might also say, well, but why doesn't it, if it can promote, why doesn't it promote C? Why not move C up the information value continuum to make it a double so that that'll work? Java won't do that because you can't make changes on the left-hand side of the equal sign. C is a variable that stores an integer value. You can't change the data type of C via recasting, nor can Java change it via automatic promotion. So it's not a line of code that you can fix on the left-hand side. All right, well, I'm on to the slide titled Activity. So we have these integer variables A, B, and C. So I have a series of statements here. If you're following along, try to think through it before I say what the answer is, to see whether you got it. You got it right, just as an indication of are you understanding this. The first statement, A equals 3.0. So what do we look at? First we look at, is there a data type mismatch? And yes, there is. 3.0 is what kind of data? It's a double. It has a decimal point. It does not have a specific data type, for instance, an F or a D, so it will take on the default data type of double. A is an integer. We have mixed data type. We have integer on the left, double on the right. That will not work. That's the example we just talked about. Okay, so what if I try to fix it by using this technique on the second line of code? So I'm going to make 3.0 explicitly double, so I don't have to rely on assuming or understanding what the default types are, and I'm just going to go ahead and recast A to a double. So now I do not have a mixed data type situation. It's theoretically it's double on both sides. Will that work? Normally in class I get a show of hands or I get a nodding of heads, and frequently I do get some people nodding yes. Lots of times also I get some people who are just kind of, their head moves around, and it seems more like maybe nausea. I don't know which category you guys are in, being that we're using a Zoom with no videos except for my own Force Ghost video. So yeah, that won't work. The reason being is what I just told you on the last slide is you can't make data type changes on the left-hand side. You cannot recast on the left-hand side, and Java will not automatically promote on the left-hand side. Doing anything on the left-hand side there is not kosher. That's just bad syntax, compiler error. Okay, third line of code, A equals recast as an int 3.0d. Will that work? So the real question is there a data type mismatch now? Well, assuming that's the right syntax, then no, because I've recast 3 as an integer. So I've got 3 on the right-hand side, and A is an integer variable, so it can hold 3. There's no data type mismatch issue, assuming the syntax is good. So is the syntax good? Yeah, that's exactly how you do it. You type in the data type that you want in parentheses, preceding the number or variable that you want to recast. Okay, let's reset A and B with some specific numbers so that we can actually get some numeric results. So if I say A is 3 and B is 2, that seems like a simple statement, but I do want you to think, can I do that? Is there a syntax error on line 4 there? A equals 3, B equals 2? No, there's not. That works fine. There's no data type mismatch. A and B are integers. 3 and 2 are integers. That's a perfectly good line of code. Okay, so line 5, C equals A divided by B. You might ask first, is there a data type mismatch issue? Or you might plug in the values for A and B. A is 3, B is 2. So you're dividing 3 by 2, figuring out what the result is, and then thinking about, is there a data type mismatch issue to fix? All right, so we've got to cast our minds back a little bit and just recall that Java will do all integer math using integer math. So it will put those variables into the microprocessor as integers and do the integer division using the appropriate operation. The result will be an integer. So there's no data type mismatch. The result on the right-hand side will be an integer, and we're trying to assign that result into the variable c, which is an integer. The issue is, okay, but what's the integer? 3 divided by 2 is not 1.5 because there's no 0.5. There's no decimal value in integer math. So 3 divided by 2 is just 1. So C will store the result 1. Assuming that that's not what you want, you really want the 1.5. The 0.5 is important to you for some reason. So let's not put the result into an integer. Let's put it into a double so we can hold that 0.5. So let's declare a new double D and set it equal to A divided by B. Will that get the result that we want? Kind of makes sense that it possibly might. But again, we start out on the right-hand side of the equal sign, which is just A divided by B. We're in the line double D equals A divided by B. A divided by B is integer math. A and B are integers. A divided by B is 1. Java will make the assignment work because it'll promote the 1 to a double to put it in the variable D. And so this is where it's possible to get confused and think maybe Java will somehow restore the 0.5 when it does the promotion. It does not, because the 0.5 never existed. A divided by B in Java here, 3 divided by 2 is 1. There is no 0.5. So the result 1 promoted to a double is 1.0. So this line D, double D equals A divided by B, the result will be that D stores the value 1.0. The 0.5 doesn't get magically restored because it never existed. All right, next line. Clearly that's not what we want, so let's use our recasting skill that we're learning, and let's recast A divided by B. So to recast A divided by B, if I want to hold on to that 0.5, if I want to have that 0.5 is a better way to say it, I need that result I need it to be done using floating point math. So I'm going to use my recasting syntax double to recast that expression A divided by B. So conceptually, it seems like it could work. Problem is, syntactically, the way I've written it will not work correctly because the parentheses around A divided by B will cause it to be executed first. And A divided by B is integer math, and the result is 1. So this line D equals recast as double A divided by B will still get us the result 1.0. There will not be a 0.5. So that's disappointing. I've got one more example in this sequence of trying to get this to work, and you might infer based on the fact that I don't have yet another one that it will work, and you'd be right. So D equals recast as double A divided by recast as double B. That'll work fine. The way to think through it is, first off, is there a data type mismatch issue? No, there's not. You've recast everything on the right-hand side as a double, So they're all double, or they're both double, is the better way to say that. Therefore, there is no data type mismatch issue. Therefore, math will proceed based on floating point, double precision floating point math, and A divided by B is 3.0 divided by 2.0, and the result is 1.5. In this example, D equals recast as double A divided by recast as double B. D will end up holding 1.5 correctly, assuming that's what you wanted as the correct result. I wish there's no easy way for me to point at what I'm talking about, but that's the line. Here, let me try this. All right. Yeah, that kind of works, I guess. That's the line I'm talking about. It's flipped on, sorry, it's flipped on my screen, so you might think, why is he having so much trouble pointing at something on screen? Is it because he's a Force ghost and has no, corporeal essence? Maybe, but it's actually just that everything's reversed on my screen. All right, A equals C. So we're all the way down, third from the last, A equals C. So I'm hoping you're looking at that right now and you're already going, what do I think about? One, is there data type mismatch? Okay, C's an integer, A's an integer. There's no data type mismatch. Then I want you to think through, is there integer division? That's the other red flag. So looking at A equals C, well, there's no division at all. So there's no integer division. So this is a perfectly good line of code. A equals C works fine. Now, if I tricked you, it's because I threw in that next example, which is A recast as an integer C. So you might have thought, wait a minute, A equals C is not going to work. Otherwise, why would he try to fix it? And that was done just to trick you. So if it did, I am sorry, A equals C works fine, as does A equals recast as int C. We said that earlier, that you can recast something that doesn't need recasting, and it's not an error. Even in this case, since C is already an integer, recasting as an integer doesn't do anything, but it's okay. Java lets you do that. And then C equals A. Is there a data type mismatch? There is not. They're both integers. That will also work fine. All right. I don't want to rush over this, so if you're looking ahead and thinking we have several slides to go, I don't know that we'll get through all the slides today, and that's okay. I'm not going to rush through this. It is, especially for business programmers who will be writing code involving, money amounts, getting the results, right is generally considered important, as it is with, any other math. Small errors can have catastrophic results, actually. There are examples online if you want to look them up on major computer failures that have led to injury and death, and they often go back to these issues that we're talking about the result not being exactly what you think it should be, or the data type being wrong, or trying to do math in a wrong data type, causing stuff to happen to rockets and satellites and other computer-based devices that have resulted in injury and death. So although monetary calculations are certainly important, it's important for everyone to understand, everyone responsible for programming computers to understand some of the details of this. The list here is meant to be a helpful guide so that you're not on the news about how a program you manage the development of caused a car crash or something. So first off, if you can get away with it, don't mix data types. Don't put yourself in the position of having to write an expression in which your understanding of what Java will do automatically is perfect. It may be, 99% of the time, but maybe not all the time. Number 2, avoid integer math. Number 3, use recasting intentionally where needed, so don't rely on Java's automatic promotion if you can, because people do get confused about when it will occur, how it will occur, what side of the equal sign it will occur, and stuff like that. You can still run into difficulties. You can you can get results that go to 0 when you don't expect them to, like 1 divided by 2. It's also possible to do stuff which results in something called not a number, which is a result that is, you might have guessed this, not really a number, 0 divided by 0, for example, or infinity. You can get results that go to infinity, which Java can also not store. So there are a variety of ways in math, in any language, to check to see, hey, has this gone to 0 when it really shouldn't have? Which again, you could just test using the double equal sign. You could say, if a double equals 0, do something to address that. Same thing with not a number. There's a method built into Java called isNaN, which you can use to test to see whether a number has gone to not a number. Same thing with infinity. There's a method available to test for that. So the idea would be to break complex calculations up into steps and check those interim results for bad things happening and address those bad things happening if and when they happen. Obviously, in a perfect world, there would be no way any data could flow into your math that would cause any of these issues. But then in the real world, stuff tends to happen like, a sensor goes offline in some piece of machinery, and all of a sudden the input number does go to infinity, and then you're using infinity in a calculation and getting 0, say, as a result, and that completely screws up what you want the device to do. Yeah, and so just being aware of this. Be cautious when combining very large and very small numbers in the same expressions. Java has trouble getting the exact correct result in those cases too. Examples on page 151 in the book. I have a second poll here I want to kick in just because we're going to change gears here a little bit, and I am just curious about these issues relating to bad results, zeros and just compiler errors, maybe trying to do simple math. You might be looking at this and thinking, I came in today being fairly confident I could do third grade math or fourth grade math, I'm not sure. And now I'm sitting at my computer thinking, I'm not sure I can do simple math simply. It's going to require a lot more thought, maybe, than I expected. And some of this has made it into the news, but it's one of those stories that often gets overlooked. But it's not a surprise to anybody who works with microprocessors or in computer science, certainly. But it does somehow end up being a surprise to the sort of the lay people in businesses, and you're not going to be one of those people after today, if you were. And there have also been famous issues with certain microprocessors having issues. There was a Pentium flaw several years ago that did result in bad results that made it into the news. So there have been examples, and or of course you might have learned this either teaching yourself to program or in a class previously. I'm going to end the poll and share it just so that you guys can see what I see. There's a split pretty much down the middle. So roughly half of you thought, no, computers are supposed to be 100% accurate. That's what they're billed as. That's what everybody assumes. Computer-based results are completely accurate and correct, and in fact, they're not. Now you know. And then some of you say, yeah, you were aware this was an issue, but not necessarily sure how to get bad results or how to trip the computer up in ways that will lead to bad results. And of course, I'm not doing that for fun. I'm not showing you ways to get bad results just because it's fun and because we enjoy laughing at the computer when it gets the wrong result, although certainly there is some joy, in that. And one of you says you were 100.00001% familiar with these issues, which was kind of meant to be funny. I'm hoping when you finish this lesson, will put yourself in one of those later, certainly, hopefully that last poll result, which is, yeah, you're aware how this works, when it works, to some extent why it works, and maybe more importantly, how to write math so that it does not occur. I want to at least get a start on the monetary calculations example. We'll finish it on Thursday, but especially for those of you who like to get ahead, I want you to know what this pirate pizza ad example is all about. So one of the things that business programmers have to do is work with results that are supposed to be monetary. They're money. You're multiplying an amount of money by an interest rate, or you're adding amounts of money together, summing them, or whatever. You're dividing amounts of money to get a rate of some sort. These are all very common calculations, and probably calculations you've already been doing in your math classes, your business math classes, to learn how to do some of these basic, say, financial calculations. But you do them typically on a calculator or in a spreadsheet. And the spreadsheet, to some extent, can take care of some of this for you, so it's not something we think about as much. But obviously, if you're programming a Java app to do this, you do need to think about it. Okay, so one of the issues is frequently when you do math in Java, if you've started doing any of these calculations homework, you'll notice when you do simple multiplications, frequently you get something with this huge long tail of digits. So you won't get 1.0, you get 0.9 16 times. Or you won't get 1.0, you'll get 1.0 and then 15 zeros and a 1. So you'll get this terrible decimal number that may not be entirely correct, depending on how you look at it. And although it's very precise, it's way more precise than money, which you want to limit to 2 decimal places, right? You can't give someone 0.000000, etc., 1 of a dollar, or your preferred currency. In general, that very fractional values that small are not handled. So what do we do? And we also, maybe even more importantly, if we're writing an app that, say, works in a restaurant and produces a receipt or a bill for the user, you don't want to present the user with a bill that says, thank you for dining here. Your bill is $39 and point, 11111111111 cents, because they'll look at you like, how do I pay that? And you might have even seen those. I have, since I've been paying attention to this, let's say for the past 20 years or so, I have gotten receipts that have done stuff like that. The tax shows up as this crazy number, the total shows up as this crazy number, or the coupon I've used results in this crazy discount number. And in the end, they've made it work in terms of the result, but you're always thinking, I wonder if that's off by a penny. It could be. And I wonder if it's off by a penny if I'm the one losing the penny, because that seems to be the way it happens. Well, also rounding. I forgot to mention the rounding part. If you round, how do you round? Most people round by rounding up at 0.5, which is called, half up rounding. The problem is that will create a bias. If you round over and over and over again during the course of a business day, you're always rounding up at 0.5, then you'll have potentially multiple calculations that resulted in something being a penny higher maybe than it should have been. And at the end of the day, that might total up to something important. Certainly if you're a bank doing millions of calculations a day, these pennies could add up, and you want to be careful about that. So you're actually not supposed to use that form of rounding with money, which is also something lots of business students don't know, and actually lots of computer science majors don't know, is there is a way to round money that is correct, and the default way is not it. So we're going to bring this to light next time. We'll start here on Pirate Pizza Ad. So if you want to look at it, it's just a little app in which it asks you to enter two prices, the price for the daily pepperoni special and the price for the veggie special, and then it adds sales tax and produces this advertisement. So it's meant to be exported as a ping that you use on your website that says, the Pirate Pizza restaurant, today's specials are, here are the 2 specials. And if you look at the screenshot, they don't look good. Obviously, I picked numbers on purpose to end up like that, but it's showing the pepperoni special as $5.2. and the veggie special as $7.0. Neither things you would want to present to the user on a receipt, on a bill, on a cash register, let alone on an advertisement. People will naturally think, if you can't even do basic math with money, how do I have any confidence at all that you're adding the ingredients up correctly in these horrible pizzas? I would be right to be a little cautious. So we will start on Pirate Pizza ad next time.